So chapter 18 is really just, it's really short. It's just about understanding sine and cosine a little bit better, and tangent, the three main trigonometric functions. The other ones are just, one over them, or just the inverses. So it goes pretty fast. It's important stuff. It's good stuff to know, but it goes pretty fast. So I'm just going to kind of go through each problem, and then you can finish them off. I'm not going to do them in great detail, but you should be able to finish them off. Okay, the first problem says to sketch sine squared, and then 1 over 1 plus sine squared. So the deal is you should be able to sketch all of the trigonometric functions, and just basically from the unit circle. So like here is the unit circle. And sine, remember, is the y value. So y value is sine of theta. And so this is 1, right? Unit circle, so a radius of 1. So sine is the up and down. So we always start here. That's just what we do in math. We start right here, right? And then we go around the circle. So what happens to sine? It starts off really quickly. Okay, my circle's not so good. It's infinite steepness here, but mine looks like it's, yeah, anyway. So starts off really fast and then slows down to get to 1. And then it starts going back to 0. And then it goes to -1, starts off fast, goes slower at the very top, and then goes back to 1. So if we graph it, and again, all you gotta do is think of the unit circle to graph it. Starts at 0, right here, and then at pi over 2, and it's easiest to use radians. You could use degrees, you could say 90 degrees, but it's just best to use radians, get used to it. So pi over 2 is 90 degrees, it hits 1. So here's 1, that's the biggest it gets. Sine, the biggest sine gets is 1. Starts off fast, and then slows down, so the slope gets less. The slope is 0 at the top. It's not changing. And then at pi, it goes down to back to 0, so it goes like this. And then at 3 pi over 2, so 3 pi over 2, it goes to -1, so -1's down here, goes to -1, and then at at 2 pi, it goes back to 0, and it keeps going on forever. And the same thing if you go negative. Let's go negative now. If you go this way around the circle at negative pi over 2, it's -1. So here's negative pi over 2. It goes down to -1. And then we know at negative pi, it goes back to here. So we go negative around the circle. It does this one the same shape on either side. Okay, so sine squared is going to look really similar. This is A, right? Sine squared is really similar. It's always going to be positive. And where it's small, a small number times a small number is even a smaller number where it's less than 1. The peak is always going to be the same, but it's always positive. You just flip this upside down. But it's a little bit steeper because the small number, any number less than 1 times a number less than 1 is even less than that number, right? 0.8 times 0.8 is 0.64. It's even less. So it's going to be a little bit steeper. Still going to get to 1, and it's always positive. So I'll let you figure that one out. And then 1 over 1 plus sine squared x. You can imagine what that's going to look like. I'll let you think about that, and you can use Desmos to graph that, but there's various ways to think about that one. Or just use Desmos, that's kind of weird. But you could probably, if you're clever, figure out a way to think about that one. Okay, cosine of x, they didn't ask for that, but remember cosine is the x value. So if you're graphing cosine, you start at 1, and then you go to 0. So cosine, you would have started here. I'll do it in green. You would have started here, and then at pi over 2, it goes down to 0. And then at pi, it's -1, so it's -1 here, and then of course it keeps going like that. And it's pi over 2 out of phase. These two peaks are pi over 2 off, right? If we took the green one and shifted it this way, pi over 2, it would be on top of the blue one. It would be on top of sine. So cosine and sine are only pi over 2 apart. They're kind of like the same thing, but they're just separated by pi over 2. Which is one of the relations in this chapter that you should write down somewhere and know. So cosine theta, and they're going to use this in another problem, is equal to sine of pi over 2 minus theta. They're pi over 2 apart. Or sine theta is the same thing as cosine of pi over 2 minus theta, because again, they're pi over 2 apart. And you could put a plus there too. It's actually plus or minus. It works either way. Okay, other relations. Sine of negative theta, if we make the angle negative, that's equal to just negative of sine theta. That's what's called an odd function, which means that sine is our blue line here, right? So if you go to the other side of the axis, if you make it negative, it's the same number. Like let's say right here, if you go to the same side, it's right here. If here it was 0.5, it'd be negative 0.5. But it's the same number, but it's negative. So if you have the negative of the angle, like right here, you're going to get the same value, but it's just negative. And cosine is the same on both sides. If we go to here, it's the same thing. So cosine of negative theta, if we take the negative of the angle, it's just the same thing as cosine. This is called an odd function, though really it's nothing to do with odd and even. It's kind of a bad term for it because it's not like odd numbers and even numbers. And cosine is considered an even function because it's the same on both sides of the y-axis. And sine is the same, but opposite. Same value, but opposite. And cosine is just the same. So those are called odd and even functions, and that is handy to know. A couple other relations that we're going to be using that they work out in the chapter. If you add pi to either one of them, so theta plus pi, that's just pi apart, it's the negative of it. You start here, pi away, it's on the bottom side. So sine of theta plus pi is just negative sine theta. Pi apart is just a negative of it. And the exact same thing with cosine. Cosine of theta plus pi is just negative cosine theta, because if they're pi apart, half a cycle apart, they're going to be, that's just the same thing but negative. And then the other one, which you can get from this, I'm using the other relations, it's kind of tricky, but is sine of pi minus theta is the same thing as sine theta. And cosine of pi minus theta is negative cosine of theta. And these are just good things to keep in mind. You can derive them, you can look at the graph it and think about why it works, or just have them ready because we're going to use those in the problems. Okay, so problem 18.2, they're just saying sketch the graphs of the absolute values. Of course, the absolute values just don't go to zero. Like cosine would just bounce up like this, right? It'd just go up like this because it can't be less than 0. Same value, but just flip them over. And tangent, so for number 2C, if we think about this, tangent theta, one way to think about tangent is it's sine over cosine. Cosine can be 0. Anywhere cosine is 0, this goes to infinity. Cosine is 0 in two places. Cosine is the x value, right? So cosine is 0 here, and cosine is 0 here. So at pi over 2 and at 3 pi over 2, tangent theta goes to infinity. It's asymptotic there. So when you graph it, it starts off at 0 when theta is 0, and then it goes to infinity at pi over 2 and at 3 pi over 2. And the same thing when it's negative. So tangent theta is a tricky one. It doesn't have a nice periodic thing like this. It goes off to infinity over and over again. And again, you can look at Desmos and stuff to see how to graph that, but you can also just figure it out by thinking what it is. The other way I think about tangent, of course, is tangent is the opposite side divided by the adjacent side. As you go really big angle, the opposite becomes 1 and the adjacent becomes 0. So it's like 1 over 0, and so again you're dividing by 0, which is infinity. So either way. And again, it's also the slope. And as you go to 90 degrees, the slope is straight up. Right? Tangent theta is like the slope. That's like y over x. The opposite is y. The adjacent is x. So here's x, here's y. And it gets really big. Y becomes 1, but x becomes 0. And the slope is infinite there, and it's straight up. Lots of ways to think about it. Okay, that's more or less number 2. Number 3 is basically using the Pythagorean theorem. So they say if cosine theta is 24 over 25, what are the two values for sine theta? Okay, so what you always do, and you should get comfortable doing it, is just draw the unit circle. So here's our unit circle. Cosine is the x value. I made it nice and big because I never make them big enough, so I'm going to try to make it nice and big. Cosine is the x value. So cosine theta is the x value, and that means it's this way. So if cosine is 24/25, that's practically 1, right? This is our unit circle, so that's 1. So man, it's like right there. So what is sine theta? So if we draw it here, let's say that's cosine's 1. So what's sine theta? So sine theta is a y value, so it's either here or here. So sine theta is like this, or those are the two places sine theta can be. So they're basically saying what is the y value, right? Because sine is the y value. So the y is sine theta. So if cosine, or the x value, is 24/25, what is the y value here? So here's our y. Our x is 24/25. See, I still didn't make my circle big enough. I have to write too small there. So all you're doing is Pythagorean theorem, because we're talking unit circle. The radius is 1. So you go x squared plus y squared is equal to 1 squared. We want y. So y squared is equal to 1 minus x squared. X is 24/25. If you keep it in fractions, it actually works out nice. I think they did that on purpose. And you can figure out the y value. Notice it's y squared, so y is going to be plus or minus, right? There's two of them. And it makes sense. There's this one and this one. There's two places where, two values for sine theta. There's a positive one, positive height, and then the negative height. So you get a plus or minus there. Okay, so that's how you do part A. I'll let you figure that out, the math. Part B is really similar. They say if sine theta is negative 0.8 and theta is in the third quadrant, what is cosine theta? So again, let's draw it. Always do this. Get used to drawing a unit circle. It makes life so much easier. Here's our circle. Sine is negative 0.8. Sine is the y value. And here's negative 1. So here the negative 0.8 is like somewhere right here. So here's negative 0.8. So that means that's the y value. So you have a point right here and a point right here in the circle. So the x value is right here. So here's our angle here. Y is 0.8 or negative 0.8, and the radius is 1. So again, they say what is cosine theta? Cosine theta is the x value. And notice there's two of them. There's also this one over here. So the x value can be negative or it can be positive. So we're going to get two answers again. And again, it's a Pythagorean theorem problem. X squared plus 0.8 squared is equal to 1 squared. Solve for x. There's two values. We know that. There's a negative 1 and a positive 1. Okay. Now part C, I'm going to finish it right here. Barely have room for it. Part C says if sine theta is 3/7, what is sine of pi over 2 minus theta? Why did I put parentheses there? Sine of pi over 2 minus theta. Well, they're basically saying what is cosine theta, because you wrote down over here before sine, come on voice, sine of pi over 2 minus theta is cosine theta. So they're asking us basically what is cosine theta. So if sine of theta equals that, what does cosine theta equal? That's what this problem is asking. So that's why these relationships are important. You should have them written down. Okay, now it's a little bit easier. Sine is 3/7. So again, okay, I should have done this on the same piece of paper, but fortunately I have more. So if there we go. So if sine is oh my god, my voice is terrible. Allergy season just kills my voice, I guess. Sine of theta is 3/7. So let's draw a unit circle. Sine of theta is 3/7. And I didn't draw it big enough, of course. So sine is the height. The height is 3/7. That's a little less than a half, right? So let's say it's right there, 3/7. What is cosine theta? So let's see, there's two values for cosine theta. There's here and here. One's going to be negative of the other one, so we know there's two. Looks like it's going to be, pretty big. So what's cosine theta? So we draw our angle there. We know the height is 3/7. So this is our y value. So y is 3/7. we want x and the radius is 1. So 3/7, so we want x, so x squared plus y squared is equal to 1 squared. Again, Pythagorean problem. If you know sine, you can figure out what cosine is, but there's two values. So we have 3/7 squared plus x squared is equal to 1 squared. We want x, we get a plus or minus, which makes sense. We get here plus or minus, and then you can figure out what that is. Okay, so again, if we know one of them, we can figure out the other one. And here, just using this relation that I wrote down earlier, sine of pi over 2 minus theta is cosine theta, and then it makes more sense. Okay, 18.4 is just figuring out what the period is. A period is a full cycle of something. So, all you gotta do is draw the picture. Like for the first one, the full cycle is just like this. So that's the answer for the first one. The second one, you can figure it out, but it's a full cycle. So for instance, this little one here, a full cycle is like from the same point to the same point. So like maybe this point here to that point there. So you draw this whole thing. Or you could say from where it starts going up in the middle to where it starts going up in the middle again. Or you could say from the peak of this one to the peak of the same one, which is right here. Lots of ways to think about it, but it's a full cycle, a full repeating pattern. So the period would be like, this whole thing here. It looks like a full repeating pattern because here it starts repeating again. And this one's a little bit tricky too. It's a full, there's a little smaller one in there, so it's a full pattern. This one's easier. The full pattern is simple. So that's all it is. All you gotta do is draw the little shape of it. Okay, it takes 10 seconds. Just draw the shape of the full cycle. Okay, and then 18.5, they say, when does basically sine theta equal cosine theta? When are they the same? So the easy way to think about it is, of course, you draw the unit circle. So I'm going to try to make it big enough now. So when is y equal to x? When does the y value equal the x value? So let's see. Y value equals the x value when we have a line. So right, this is saying when does y equal x? Well, that's just our line with the 45-degree angle like this. Right, that's right when y equals x, that's our line. So when does that happen? That happens when it's 45 degrees. We know the slope is 1 there, 45-degree angle. So when theta is 45 degrees, which is the same thing as, let's see, pi over 2 is 90 degrees. So 45 degrees is half of that, so it's 1/2 of pi over 2. So it's pi over 4. So they are equal at pi over 4, but they're also equal here. Here they're both positive. At 45 degrees they're both positive. X is positive, y is positive. And here they're both negative, right? Y is negative, x is negative. So there's two places at pi over 4. So this happens at pi over 4. And it happens way down here, which, okay, we got to figure out what that angle is, right? All the way around to here. And that is, let's see, pi plus pi over 4. That's one way to think about it. Or we could go 3 pi over 2 minus pi over 4. Let's do pi plus pi over 4. So what's that? So it's pi, which is right here, plus pi over 4 more, 45 degrees more. So pi plus pi over 4, we got to change that to fourths. That's 4 pi over 4 plus pi over 4, which is 5 pi over 4. So that's 5 pi over 4. So it's pi over 4 and 5 pi over 4 is when they're equal. When the x value is the same as the y value. Yep, so which is pi over, that's at the angle pi over 4. The other thing you should be able to do is figure out what that value is. The radius is 1, so if we draw this triangle, let's draw this triangle here, right? The radius is 1 because it's our unit circle. So we have x squared plus y squared equals 1 squared. So x squared plus y squared equals 1 squared. However, x and y are the same. That's the whole point. It's an isosceles triangle. The x and y values are the same. So we have x squared plus x squared equals 1, or 2x squared equals 1, or x squared is equal to 1/2, or x is equal to 1 over square root of 2, which is, people don't like writing it that way, so you multiply top and bottom by square root of 2. Square root of 2 is 2, so we have root 2 over 2. So that is what the x value is, root 2 over 2. Root 2 is like 1.414. Divide that by 2 and it's like 0.707 and goes on forever. If you ever see 0.707, you think, oh wait, that's the square root of 2 over 2. That's half the square root of 2. And that's the number that comes up a whole lot. So that's what that value is, root 2 over 2. So y is, that's what x is at 45 degrees. All right, that's pretty much chapter 18. Really short, should finish these up real quickly. I basically did most of it, or showed you how you can finish it on your own. And then we'll have a quiz on 17 and 18, and then we'll get to chapters 19 and 20. Okay.